Hi, and welcome to our discussion on measurement rules. Today we're going to be talking about measurement and the role estimating plays in making measurements. We'll talk about measurement rules and we'll do a little measurement practice. Let's get started. So in measuring, the last digit in any measurement is an estimate. As people, we're pretty good at estimating stuff, and because we want the best measurement possible, we allow for one estimation in our measurement. What that means is, when you see a number like 34.8 miles, that means that this last thing written down, this last digit, is an estimate. It wasn't maybe exactly 8, it looked like 8, but it may have been a 7 or a 9. It was someone's estimate of what they thought it was. Just like in 2.36 seconds, this 6 is an estimate. We knew it was a 3 here and a 2 here, but this 6 maybe not so much. And the same with this one, the 4 is an estimate, the 7 is an estimate, and the 5 is an estimate. So that last number written down is an estimation of what we thought it was. It may not be exactly that. What that means is then that there are no such things as perfect measurements, right? That every estimate has this last little estimate. So if someone were to say, hey, I thought this was 34.7 miles, that would be totally acceptable. This last estimated digit will be different from different people. It may also be the same, but it can be different. Now as we start talking about the measurement rules, these rules are going to stem from the fact that all measurements end in an estimate. So the basic idea of the rule is that we keep measuring something until we have to estimate a value. And once you make one estimate, you're done writing numbers. So all measurements have one and only one measurement. Okay? Another way of saying this is that we estimate a measurement one place past the smallest increment. Now the smallest increment is the little lines, the smallest little lines on a measuring device. If you figure out how much each of those little lines is worth, typically we measure one place past that in terms of the decimals. Let's take a look at an example of that. Before we actually measure, it's going to be helpful that we actually figure out what the smallest increment is. So how big is each little line? So we come in here, we can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 little increments, little pieces in here. So that means each piece must be 1/10 of a centimeter, which is 0.1. So our smallest increment then is 0.1 centimeters. It's going up by 0.1 centimeters every time. So now we know from our measurement rule that we're going to measure one place past. So we should expect our measurement to be in the hundredths place, not the tenths place. Let's take a look though. Now as we do this measurement, we know it's at least 1. There's no estimating there. We know it's not 2, it's more than 1, so 1. We have not estimated yet. Now we know that it's 1, 2, 3, 4, 5. It's more than 0.5 but less than 0.6, so we know this next number has to be a 5. There's no way it's 6, it's not there yet. So still, we haven't estimated. We know these two numbers for sure. Our estimate comes in when we estimate how far between the 5 and the 6. So here is 1.5, here is 1.6, and you can see here it's slightly closer to the 6 than it is to the 5. If it was exactly halfway in the middle, we would put another 5. But because it's slightly closer to the 6, we might put a 6. So 1.56, and this is our estimate. We don't know this for sure. So what this means is if you put 1.57, that's totally correct as well. If you put 1.55, that's totally correct as well. In fact, even on this one, we might even give you 1.58 centimeters. It's an estimate. All of these are the same value. So when we write 1.57, what we really mean is that, hey, it could be 1.55, 1.56, or 1.58. We mean all of these measurements are bound up into one number. Let's practice a few together. So here our smallest increment. We have 5, 10, and we have 1, 2, 3, 4, 5 segments in between 0 and 5. That means each increment, each line, must be a total of 1 centimeter. Awesome. And now we're going to measure until we have to estimate. So right now we know this is 6, 7, 8, and that one's 9. So our measurement is somewhere between 8 and 9, so we know it's 8 for sure. It's definitely not 9. But now we have to figure out how far between 8 and 9, and this one looks really close, so there's 8 here, 9 here. This one looks really close to 9, So I'm going to put a high number here of something like 8.7 centimeters. Now what this means, of course, is that 7 is an estimate. So when I say 8.7, what I'm telling you is, hey, this could be 8.6 centimeters. It could be 8.8 centimeters. It could be maybe even 8.9 centimeters. So we're saying all of these numbers when we say that one measurement. All right. This next one's tricky. Let's take the bottom one. So we're going up here 100, 200. So our smallest increment is 100. Now we know it's more than 100 but less than 200, so we know 100 for sure. We haven't estimated yet. But this next one we look at and we go, oh wait, geez, I don't know where that is. It looks like it's about maybe 20 or 30. So we say, okay, 120, we choose one. We could have said 130. Notice how this place is our estimated place. Now a lot of people on this one would want to say, oh, that looks like 125 because it's a quarter of the way over. Here's the problem with saying that. When you say 125, you said, my 5 is an estimate, but I knew where the 20 was. And that is just not true. We have no idea where the 20 was. So when you say this, you are telling a lie. You are saying, hey, I don't know the 5. I guessed that one. I estimated that one. And the 2 I knew for sure. And that's just not true. So this is an absolutely wrong answer. All right, another one. Let's see. So we have from 0 to 100, and we have 50 here, and we have 1, 2, 3, 4, 5 segments from 0 to 50, making each one 10 centimeters. So let's measure. So we know that it's 1, 2, 3, 4, it's between 40 and 50, so we know that it's got to be 40 something at least, so that's not an estimate yet. But now I'm looking, I'm saying, hey, that looks like it's about halfway. So I'm going to say that's 45 centimeters. Now that means, of course, is I could have said 44 centimeters. I could have said 46 centimeters. Right? Here, I wouldn't want to say 49 centimeters. That's too far off. That's not good estimating. All right, last one. So on this one, if I look at this smallest increment, I see that it's going up. I have 1 here, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 increments. So this is 1/10 of a centimeter, so that must be 0.1 centimeters. Now my measurement here, I know that it's going to be, here's 1, 2, 3, 4, 5, 6, 7. It's more than 7 but less than 8, so I know that's going to be 0.7 so far. I know that one for sure. And now I have to estimate how far it is between the 0.7 and the 0.8. And of course, it's really close to the 7, so I'm going to put something small here, like a 2. Now, of course, what that means is this could be 0.71 centimeters as well, or 0.73 centimeters. It's whatever you estimated it to in these small numbers. All right, now it's your turn to practice. Go ahead and pause the video, write down a measurement for each of these 4 rulers, and then hit the video, hit play, and we'll go through them real quick. All right, so on this first one, we have a smallest increment of 10 centimeters. So I'm going to write the increments here. So our measurement then is 50, 60, 70. We know the 7 for sure. And then we have to say how far between 70 and 80 it is. And it's most of the way. So maybe this is something like 78 centimeters, which means it could be 77 centimeters. It could be 79 centimeters. And maybe even as little as 76 centimeters. Now, if you put 75 or 74, 73, 72, 71, those are going to be wrong answers. So make sure you're one of these 4. It's really the range we're looking for. This next one, this is 1, 2, 3, 4. So our smallest increment is 1 centimeter. And we know it's between 4 and 5, so it's 4 something. And that something looks about halfway, so I'm going to put 5. Now, of course, that means it could be 4.4 centimeters or 4.6 centimeters. All right. So this next one we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's a 1/10 each. So our increment is 0.1 centimeters. So we do our measurement. We know it's 1 for sure because it's more than 1 but less than 2. We know it's 2, 1, 2, 3. So it's between 0.2 and 0.3. So we know it's definitely 0.2 something. And then we estimate the last one. It looks like it's about 7 centimeters. So on this one, 1.26 centimeters would work, 1.28 centimeters would work, I would say those are the three good ones you can have. Now this next one's super tricky. Check this out. We know it goes up by 100 each, so our increment is 100 centimeters apiece. So that means when I look at this one, I'm like, wow, I'm already estimating. I don't know where anything is. So I look on here and I say, this looks like about 80 centimeters to me, which means maybe you could have said 90 centimeters, and maybe you could have said 70 centimeters. Now check this for sure. If you said 75, or if you said 83 centimeters, or if you said 76 centimeters, anything with that ones place, watch what that tells you. It says, I estimated the 5, but I knew where the 7 was. And you don't know where the 7 is. That's a lie. You said, I estimated the 3, but I knew where the 8 was. That's a lie. You said, I estimated the 6, but I knew where the 7 was. That's a lie. It cannot have anything in the ones place because we're already estimating on the tens place. All right, well, that does it for our measurement video. I hope it helped you, and if you need any extra help, feel free to stop by and talk to me in class.